Hey everyone, welcome back to the channel. Today we're breaking down a fundamental concept in the world of engines, the compression ratio. If you've ever wondered why it matters, how it's calculated, and what role it plays in performance and efficiency, stick around because this video will make it crystal clear. Compression ratio, often abbreviated as CR, is simply the ratio of the volume inside a cylinder when the piston is all the way at the bottom of the stroke, compared to the volume left when the piston is at the top of the stroke. In other words, it compares how much the air-fuel mixture is squeezed before ignition. A higher compression ratio means the mixture is compressed into a smaller space, while a lower ratio means it's not compressed as much. To really understand compression ratio, we need to know three important terms. 1. Swept volume. This is the volume displaced by the piston as it moves from bottom dead center to top dead center. It's calculated using the bore and stroke, and when multiplied across all cylinders, it gives the total engine displacement. 2. Clearance volume. Even when the piston is at the top, there's still a small gap above it. That leftover space is called the clearance volume. 3. Total volume. This is the volume of the cylinder when the piston is at bottom dead center. It is the sum of the swept volume and the clearance volume. The formula for compression ratio is straightforward. Compression ratio equals volume in cylinder at BDC divided by volume in cylinder at TDC. Or compression ratio equals swept volume plus clearance volume divided by clearance volume. Now let's look at what happens if the compression is too low or too high. If compression is lower than normal, the engine will produce less power, fuel economy will suffer, but it will be easier to crank and start the engine. If compression is higher than normal, the engine has the potential to make more power and deliver better fuel economy, but it will be harder to crank, especially when the engine is hot. This comparison clearly shows the trade-offs between low and high compression ratios, and why keeping the compression within the correct range is so important for both performance and reliability. Anytime an engine is modified, the compression ratio should always be checked to make sure it's still within the proper range. Changing engine components can raise or lower compression, and that directly affects performance, efficiency, and durability. There are two major factors that can affect the compression ratio. The first is head gasket thickness. If you install a thicker than stock gasket, the clearance volume increases, which lowers the compression ratio. On the other hand, using a thinner gasket reduces the clearance volume, which raises the compression ratio. The second factor is increasing the cylinder size. When the bore or stroke of the engine is enlarged, the swept volume becomes bigger. That means more air is squeezed into the same clearance volume, and as a result, the compression ratio increases. And that's a wrap on compression ratio. Now you know how total volume, swept volume, and clearance volume all play a role, and why getting the compression just right is so important for power, fuel economy, and reliability. If you found this video helpful, don't forget to hit that like button, subscribe for more deep dive engine content, and drop a comment below with your engine's compression ratio. Thanks for watching, and I'll see you in the next one.